Welcome, everyone. Thank you very much for taking time on a Saturday to come to this very first virtual Tezos Berlin meetup. I think we may have to do more of them in the future, depending on how the global situation evolves over time now. So today I'm going to, the next 30 minutes or so, talk about 006 Bond. I think it's a fantastic opportunity that we have a protocol upgrade called 007. It's called Bond because also the new Bond movie is going to come out. I think they postponed it, but it was supposed to come out in the next couple of months. So with that, let's get started. So I'm Adrian. And to give you a little bit of background on myself, I'm fundamentally a protocol engineer and researcher. And I also am the founder of Cryptium Labs and Metastate. So to give you a little bit of context and background on Cryptium Labs does three main things. The first one is protocol engineering and research. So in conjunction with Nomadic, we shipped 005 and 006, so the last two upgrades to the Tezos network. And right now we're working on 007, 007, and in the future we'll be working on 008, 009, again with the other core team being Nomadic. This is the first part that Cryptium Labs does. The second part is programming language research and engineering. So we built a language called Juvix. It's a dependently typed language that should make it very easy to write secure proof-carrying smart contracts. There you can expect the first public release to happen late summer 2020. And yeah, I'm very excited to be able to share this with everyone. And the third thing we're working on is zero-knowledge engineering. So we're currently building something that we internally call the MASP, the multi-asset shielded pool. That gives, instead of having single asset privacy, as is currently the case in Zcash, will give you privacy, but for many different types of assets at the same time. For that, we probably have to do a trusted setup, and that should start sometime in late summer 2020 as well. Of course, there will be more communication about it. And as well, there will be a protocol upgrade for this sometime in late 2020. This is a little bit of background into Cryptium Labs and Metastate. You can find us on Twitter at Cryptium Labs, or Metastate you can find on the website. Sadly, you haven't been able to secure that yet, but check it out. There's more information on all of this. This talk, though, is about 007 Bond and its possible features. So Marco will specifically talk about the sapling integration in his talk, and I will specifically talk about stateful baking accounts in this talk right now. Lastly, I'll also share some ideas for a long-term roadmap for Tezos, but that sort of comes towards the end. Okay, so how do I move slides now? There. Okay, let's start with a quick recap of 005 and 006. So 005 was injected in summer 2019, roughly, and 006 then was injected in winter 2019. Babylon, or 005, was a very large feature proposal. Whereas 006 was much more of a housekeeping proposal to make sure that we sort of maintain a nice state of the code base and do some small fix-ups. So as for the major features in each, so in 005, we overhauled the delegation system. It was effectively a massive simplification of the delegation model that made TESI1 accounts, or implicit accounts, generally speaking, delegatable. Besides this, we also introduced quorum caps so that even if there's very low participation in governance over a long period of time, that the quorum will adjust to this so that we never get gridlocked into a situation where we don't have enough people participating and hence nothing can happen anymore. And lastly, there was also ME+, which was there to halve the consensus against some long-term attacks. There was 005, sort of in a nutshell. Then 006, there was ME+. We had some fixes, or ME++, I guess, some fixes to precision bugs. We also bumped the gas limit by about 30% in 006. So we increased the set of possible smart contracts that can be written in Michelson and deployed to Tezos. And lastly, we introduced some Michelson improvements, specifically around the gas cost of specific opcodes. Cool. So in the remainder of this talk, I would like to give everyone an overview of 007 and the possible features that it could include. But it's important to stress that these are possible features that the two core development teams in Cryptium Labs and Nomadic are working on. In the end, it's always up to the community to review and adopt these features through the governance process on chain. I mean, I hope everyone here is well aware of the governance process that Tezos has. If not, this is a perfect opportunity to sort of ask questions, and then I'll explain it later on. By the way, I'm not sure if I see questions. Okay, so there seems to be no questions for now. I'll check in from time to time to see if there are questions, and feel free to just post them in the chat. For 007, it should be ready for injection sometime in summer 2020, so about a year after 005 was ready. I think the cadence is most likely going to work out that we're looking at upgrades roughly every 6 months or so. Okay, next slide. So what are currently the planned features to go into 007? Well, we have the sapling integration. Marco will focus on this. We have stateful baking accounts, and I will focus on this. We also have an environment upgrade, which in essence will mean that we will modify or improve the shell to expose a bunch of new functionality to the protocol so that we can leverage, for example, some new cryptography within the protocol. This, however, means that for 007, everyone will have to redeploy the shell because the protocol in itself can still be voted up on chain, but it requires a new version of the environment. And this cannot be installed and downloaded on chain, but rather everyone has to manually upgrade their shell. Then we also have some cryptographic additions in 007. Specifically, I'll focus here on BLS 12381. So it is really convenient if you have the ability to very cheaply do some certain cryptographic operations on specific curves, in this case, BLS 12381, within Michelson. It allows you, for example, to write a ZK snark verifier for an arbitrary circuit that you design. So for example, let's say someone right now wants to build a private voting application. Currently deploying this to Tezos is going to be prohibitively expensive because we don't have any of the underlying cryptographic primitives that they need to build this kind of zero-knowledge verifier. But with the cryptographic additions, this will be possible to deploy. This is also going to be tremendously helpful for all the layer 2 stuff. So people that talk about ZK rollups a lot, people talk a lot about ZK rollups in Ethereum, and this will make ZK rollups very possible in Tezos as well. There was some discussion around which curves to add, but in the end, I think we should be going with BLS 12381 because it's sort of the industry standard that we will be moving towards. Next, we're also working on secure randomness, specifically PVSS, publicly verifiable secret sharing. It's an improvement in the randomness generation that Tezos currently has, and it sort of can be run in addition to the commit reveal scheme that we currently have. This is just going to be the addition of it into the protocol. This doesn't mean activation yet. This has to be a 2-step activation. So before we can expose this publicly to, for example, smart contract developers, we still at least need one other upgrade. Then we also have some amount of governance upgrades that we're working on. So vote overriding, specifically allowing delegators that have at least one role with a baker to change the vote of their baker. And then also vote splitting, allowing bakers to vote proportionally for different proposals, for example. For example, they could upvote 70-30, 70-30, 2 different proposals. This is in order to allow specifically large bakers, large public bakers and exchanges to represent very well the set of their delegators, right? Because if you're Coinbase, you have a real problem that maybe you have only one baking account, but half of your depositors, customers want to vote for A, the other wants to vote for B. What do? You either don't vote at all, which is what they currently do, or you can say you sort of pass this through onto the customers and let them decide, and then you just vote proportionally to what the delegates want. Moreover, this is actually the 5th voting period is actually something that came out of 005, because we realized a lot of people, especially wallets and exchanges, didn't want to spend engineering man hours before they were certain the protocol gets adopted. Due to that, some larger exchanges were actually relatively late in adopting 005, because only once it had been activated and sort of everyone knew this was going to be the thing we're going with, did they bother spending the engineering time in order to adapt their own systems to it. So the fifth voting period is really about saying that after the fourth one, we are certain that it will get adopted, but we don't activate it for, let's say, another 3 weeks. And then, so now you have the get your shit together period. So you have 3 weeks to spend your engineering man hours on adapting to the new protocol, and only then does it get activated. And the last governance improvements is protocol sources. Simply stated, currently the sources of the new protocol aren't on chain. We only have a pre-image, so we only have the hash of it. And this protocol sources change would mean that we ship the actual protocol sources within the chain. And then, oh wow, actually, damn it, my slides are, I just realized my slides are slightly cut off. Well, in any case, I can read it for you. So on usability, we're also working on something called meta transactions, which simply stated again allows an arbitrary person to pay for someone else's transaction fees. So for example, I could want to invoke a smart contract in order to use a dApp, but I don't necessarily hold XTZ myself, but I can send it to the dApp authors, and the dApp authors can pay for the inclusion and the execution of my transaction on my behalf. So if no other system has this yet, Ethereum is trying to do a bunch of hacks, the gas station network, but we can simply implement this in the core protocol. And the last thing is some more Mikkels improvements. So something to facilitate the interoperability of high-level languages, caching of deserialization of smart contracts to make CPS patterns cheaper, and maybe also accessing state of smart contracts more easily. Wait, I need to go to the next slide. Right. So this was the rough overview of what I expect 007 to look like. Of course, there may still be small additions and removals. We'll see. This will sort of stabilize over the next couple of months. But most of these things are fairly well advanced and should be ready for integration for injection by summer 2020. Okay, now let's briefly take a step back here and think about the long-term context of Tezos and the wider blockchain industry. So Tezos is getting better and better with every upgrade. And this is really what I find the most fascinating feature of Tezos, that instead of saying we have a system now and sort of in 5 years from now, we do a magical upgrade where we go from the Stone Age to space travel. That's the Ethereum model, by the way. We say, no, this seems really stupid. This is not how real world systems are developed and updated over time. Let's instead focus on shipping regular upgrades every 6 months or so in order to incrementally make the system better. And I'm really optimistic that this is going to work out very well, and that in 5 years, we do not recognize what Tezos has become. Like it can be something that we couldn't imagine 5 years ago. That's sort of what I'm saying. But now we've seen sort of 3 major upgrades, I guess, with Athens, Babylon, and Carthage. So 004 to 006. It shouldn't give us this false sense of security because it's really important to remember here, the majority of the road is still in front of us. We are still really far from having usable, public, decentralized, and censorship-resistant blockchains. What we currently have are sort of early research prototypes, but they are nowhere near yet usable by hundreds of millions of people daily. And we really shouldn't set the bar as to comparing ourselves to something like Bitcoin or Ethereum, because they're outdated. Maybe Ethereum 2 will work, maybe it won't. No one knows. But Bitcoin is definitely outdated at this point, in my opinion. This is not going to be the use case of 100 million people a day. So we should aim for something that is much better than current Ethereum and much better than current Bitcoin. And we also need to remember that in 2020, we'll see a bunch of new platforms launching. So we'll see something like Near, Solana, Polkadot, Celo, maybe some others, maybe Coda as well, new Cypher, we'll see. They are planning to launch in 2020. And they're going to start from very advanced baselines. Like if we stop evolving right now, these protocols will eventually just replace us. So it's really important to keep in mind that we need this constant long-term evolution. We need to spend a lot of resources in making sure that the core protocol evolves over time. It does not fall behind, because the status quo, if we stay with the status quo, it means we're starting to fall behind. So if we stop evolving, we'll be replaced by better platforms. Interesting enough on this, not yet launched chains have somewhat a development speed advantage, because they can just think of something, build it, and they don't have to compete with the status quo, right? In a live system, we have to convince a bunch of people that what we have come up with and implemented is better than the status quo. Like in a new system, you can just say, this is now the status quo. In a live system, we have to say, well, this is the status quo, and this is what we're thinking, and this is clearly why it's preferable over the status quo. And as well, other people are starting to build on top of Tezos, right? And they maybe don't fully yet understand that we need constant evolution. So they will push towards stability. But we really need to make sure that we balance this need for speed with the need for stability. We definitely don't want to be in the camp where we only have stability and no development. But we probably also don't want to be in the camp where we only have development and no stability. We probably want to find somewhere like a sweet middle. Okay, so now that we've talked about this, let's jump into stateful baking accounts. So I'll quickly start by describing the current state of bakers. And I think I call this current simple bakers. Afterwards, I'll explain the motivation for the new system, or where we can improve on the status quo. Then I'll describe the implementation. And lastly, I'll describe the migration. Because again, this is a live system. It's not just enough to build the new feature. No, you also have to think about how do I transition the existing system to the new system, right? How do I go from status quo to the new system? How do I take, for example, how do I take 70,000 old KD1 accounts to the new delegation system? This is something we have to think about in 005. And in stateful baking accounts, we also have to think about how do we take existing bakers and migrate them to the new system. Okay. Big marker gobbled up my slides a little bit. Okay, doesn't matter. They are still somewhat readable. So the current simple bakers, this is the way bakers work right now in Tezos. There's a single private key that controls the baker, right? So you all know the baker addresses, they're just simple account addresses, simple implicit accounts. And the way that you tell the system that you want to be a baker is you self-delegate. So key A delegates to key A, and that means this key is now a baker. It also means that, and the current system also has the same key for all functions, right? Whether it's signing blocks in consensus, sending a transaction, or voting in governance. It's all fundamentally the same key. So the operator and consensus keys are identical, even though we may not want to have them be identical. And I'll come back to this now. Right, so what is the motivation for stateful baking accounts? Well, for one, we want to have the ability to change the operator key. If Tezos Tezos has gotten a lot of traction, and it means that bakers are becoming an incredibly important security cornerstone of the system, right? Because in the end, Tezos is proof of stake. And we need to give bakers the ability to better protect their bakers. We need to help them become professional organizations. And it's really hard to do this if the only thing that you have to work with is a single private key, because someone fundamentally needs to back up this key, needs to have access to sign with this key. But instead, what's normally much better model for the operator key is to have a multi-sig. So just saying there may be 3 people in the organization that's running this baker, and for any action, whether it's voting or spending, you need 2 out of 3 people to agree. Of course, this doesn't apply to the consensus key. The consensus key doesn't have to be a multi-sig. It's a hotkey that lives on a server somewhere, or ideally in an HSM, and needs to constantly sign blocks. Now talking about the consensus key. We want the ability to rotate consensus keys. And sort of here I've listed the reason for this as that you may want to adopt new cryptography, such as BLS. So BLS allows you to do signature aggregation if you're signing over the same thing. It means that if every baker were to upgrade or change to BLS key, we could potentially reduce the amount of space in a block that we need to take up for the signatures of endorsements. But for this, we need the ability in the system to be able to change the consensus key. The other point that I didn't mention here for the motivation to change consensus keys is that a lot of bakers started very small, right? Like Cryptium, we also run a baker, and when we started, we sort of expected to be tiny. We started with one role. But over time, this grew, and a lot of people set up their initial keys not with the idea in mind that they'd run multi-million-dollar bakers, but rather they run small homegrown bakers. And so giving them the ability to harden the cryptographic setup around the baking keys is really important, not just for themselves as baker, but also for the security of the network. And lastly, we want to be able to have some sort of structure around bakers so that we can add more types of keys. For example, PVSS requires a completely separate new key. And in the current system, we can't add this because, right, a baker is just a single public key hash. That's it. There's no structure around it. We don't have the ability to add a new key to it. But for example, we want to have the ability to add PVSS keys. Maybe we want to have the ability to add testnet keys so that bakers can publicly add a key that they want to be able to use, that they want to use in the testnets. All sorts of things. So now that we've talked about the motivation, let's quickly go through the implementation. And I mean quickly, I'm actually realizing I'm running out of time, so I haven't given this talk before, so I may run over time a little bit, but we'll see. So for the implementation, currently bakers, as you can see on the left side, are just simple public key hashes. What Stateful Bacon accounts does, it creates a structure around them. You can, if you program, you can think of it like a struct. It creates a struct around it. So, and the struct is a baking account that starts with the SG1 prefix. So you can sort of think of it, it's a different type of account in the system. It's a baker account. And you can create this by registering as a baker. So if I want to be a new baker, I say register as a baker. And then the system under the hood creates a structure. This SG1 gets generated, and it uses my private key as a consensus key and the operator key. And over time, we can add new elements to this. So currently, I think in 7, it will this structure, the baking account structure, will contain a consensus key, an operator key, and the PVSS key. But over time, we can think about adding different types of keys here. So as we think the system may evolve over time. And so why is this structure, why is this baking account really important? Well, currently, all delegations point directly to the public key hash, right? So on the left side, you see this. So you have a bounded set of bakers, because you have to have at least one role to be a baker. And so due to that, the state machine can iterate over the set of bakers. But we want to allow anyone, no matter how few XYZ they hold, to be a delegator. So the list of delegators is a completely unbounded set. It's potentially infinite, right? Someone with half an XYZ can be a kind of a delegation to some baker. And this means that currently we can't, for example, rotate the consensus key or even add an operator key, because it would mean that we'd have to update this potentially unbounded set of delegators, because the delegators fundamentally point to the baker. Whereas with stateful baking accounts, the way it will look like is that you have a set of delegators, and the delegations point to the stable permanent identifier, which is the SG1 account. And then within the structure, we have a consensus key, we have an operator key, and we have a PVSS key. And we can modify them independently. This is not to say that we want to allow arbitrary modifications, but because the protocol, of course, always restrict this, and we start with the most restrictive subset possible, but it at least gives us the ability to rotate the consensus keys. So, right. So now talking about the operator key. So the operator key is going to be represented by formally verified smart contract, formally verified multi-sig smart contract that is currently available in the Tezos client anyway that you can use for spending. It looks very similar. And that single multi-sig controls all functions of the Baker. So there aren't different keys for spending and voting or changing consensus keys. No, there's only one multi-sig that has the same threshold for all operations. And this multi-sig can spend, vote, and rotate the consensus key, as well as add new keys such as PVSS. Okay, and now, lastly, let's talk about what this looks like to, for example, rotate the consensus key. Well, changes to consensus key cannot be used to, for example, avoid getting slashed due to double baking, right? Like if you double bake, even like in the new stateful baking accounts, you will still get penalized. You'll still lose your security deposits if you double bake, because the changes to consensus key have a 7-cycle delay. This is super interesting to me as a protocol engineer because technically a baker can change its consensus key every single block. But what really matters is what is recorded in the snapshot that gets selected in 7 cycles from now. And again, it's really important to understand that this doesn't affect the SG1 identifier. As you can see here, the SG1 account changes consensus key from TESI1 ENQ to a TESI2 address, but it didn't change the above SG1 identifier. So due to that, we don't have to iterate over all delegations in the system. And so the same happens with the multisig, right? You can change the key within the multisig, but it won't affect the overall baker address. Oh yeah, and right, yep. So now let's talk about migrations, because as I mentioned earlier, we are a live system, so we not only have to worry about building the feature, we also have to worry about migrating from the existing system to the new system. What sort of at a very high level happens in the migration is that all bakers are allocated a new SG1 baking account. Sort of we collect the list of all bakers, and this will happen at the migration block. At the migration block, we get all the bakers, and we slowly go through every single one. And then, so we are baker 1, and then for baker 1, we generate a new SG1 address that is generated very much the same way that KT1 addresses are currently generated, so you just hash nonce. The consensus key is set to the original baking key, and the operator key is set to the original as a 1 out of 1 multisig with the original baking key as well. That means that if I'm a baker migration, I have a single key that I use to control my baker. After the migration, it's still the same thing. I still have a single key that controls my baker, but I now have the ability to rotate the consensus key if I want to, or add someone to the multisig. And the PVSS key is left empty, and bakers will have a couple of months time to submit a new first PVSS key to the protocol, so that in a later protocol upgrade, we could activate PVSS. God damn it, the slide. Oh, right, it's not the right font, I see. Right, what happens to the delegators during this migration? Well, for all delegators, we sort of pay a one-time cost here, where we have to step over the list of all delegators, because currently they're pointing to a specific public key hash of an implicit account, for example, some TESI1 address, and we have to correctly update this TESI1 address, this pointer. If you remember this pointer here, right, we have to update this pointer to not just point to the TESI1 address or the implicit account, but rather point to the SG1 account. There. Wait, I was on slide earlier. There. Yeah. So this is going to be a rather large migration. This takes roughly ON time, where N is the number of total delegations. ON is important to note. Bakers have some time before PVSS actually becomes active. We need another protocol upgrade to actually activate it. So bakers will have plenty of time to get familiar with the system and add a PVSS key. Right. As with 005, we did the same thing, right? We removed the ability to have this sort of special purpose KT1 account that doesn't have code, but is rather just a delegation. And instead, we implemented the same functionality in Mickelson. We're doing the same thing here effectively. So the current baker behavior is still available. So any future baker that just wants to have a single private key that controls everything, that works. They can just, they register as a baker, they give their single private key, and now they have exactly the same setup as they had before the migration. Secondly, the current Tezos client commands will work without a change in the new system. So the Tezos client can be very smart because we can sort of encode a bunch of knowledge about what this migration did, so that we don't have to change the command. So of course, the new commands, if you want, you can use those, but you don't even have to learn new commands. The old commands just work, and the Tezos client just does something really smart under the hood in order to make that work. Of course, wallets, tooling, and exchanges will need to adapt, will need to be adapted to some extent. And here you're actually missing the last bullet point, which is migration documentation will, of course, be available before this upgrade activates. But again, remember, we need to, some breakage of existing tooling is sort of unavoidable if we actually want to improve over time. Okay, that was it on stateful baking accounts. I hope this was insightful. I didn't check the questions. Maybe I should quickly do this now. Okay, I think we said we collect questions after. Okay, cool. So now let's quickly go maybe the last 5 minutes and talk about beyond 007. Again, remember, this is a tentative list that gets updated and changed all the time. So don't be sad if something that you would like is not on this list. Please sort of let us know in the forums or over Twitter, doesn't matter. And please also don't be sad if something gets removed. This is just how it happens. Right, so my high level idea of what I hope these systems, well, what I think these systems need to be generally useful by the general public to actually have a real use case there is we need a fair amount of work and consensus. We need some fast finality, most likely through a finality gadget. We need lower latency blocks. This is maybe coming in 009. Lower latency blocks meaning shorter block times, right? Like waiting 30 seconds or a minute for a transaction to get included is not great UX. We need privacy, multi-asset shield pool. Sapling will already help a lot with this, especially for XTZ as sort of a payment utility. But with the multi-asset shield pool, we're really expanding this to also include things like tokens. We need scalability, so higher throughput. This is not only the number of transactions that can be included, but also the complexity of individual transactions, right? There's currently a bound on how complex a smart contract can be due to the gas limits. And so scalability is also about allowing more and more complex smart contracts to exist on the system. Then there's also a point on secure interactions with the chain. Currently, most people simply trust an indexer or some full node that they don't control. But the indexers or the full nodes can always lie to the clients, which is a real problem. So what we need is a light client for instance, and then that way light clients can sort of do Merkle-proof verification in order to see, and then they would at least know if a full node is or an indexer is lying to them. I think another important area will also be secure smart contract, so maybe novel execution environments. And lastly, trustless interoperabilities, so bridges to other chains. This is really, maybe the full-fledged idea would be that we want to have IBC between Tezos and other systems, right? So secure two-way trustless bridges, so that you can take one ETH, move it into Tezos, and do some computation in Tezos, but they're fully fungible. Whether the ETH sits on Ethereum or on Tezos doesn't matter. At the very least, though, we want to have the ability to read state from other chains trustlessly and securely, right? It'd be very nice to be able to have notifications of, let's say, some Bitcoin transaction happening and being able to verify that this actually happened on the Bitcoin main chain with a high probability of finality on Bitcoin. And that, because then we can start building systems in Tezos that react to things happening outside of Tezos. This is sort of my quick overview of what I'd like to see sort of beyond 0 to 7. This is probably the next 2 to 3 years in terms of actual development time. But yeah, thank you very much. I hope that this talk was interesting. And yeah, please come find me on Twitter, find Cryptium Labs on Twitter or Metastate on the internet. And thank you very much. I'm open for any questions if we have time.